So we're back to an example that has a freebie. So we should notice there is a freebie over here in the x's. You'll see why in a second that I'm giving this example later, that it is a little bit trickier, weird situation. But we're going to make our note to ourselves that we're going to eliminate x's. We're going to make our little note over here that we're going to end up with two equations, two unknowns. And we're going to take our freebie. So we're going to copy down equation 1, that's the freebie. And now we're going to eliminate the x's in a different way. So we're going to look at equations 2 and 3 and say, if I multiply by -1 on that second equation, that looks good. So let's come to scrap paper land over here. We're going to distribute the negative across that second equation. We're going to copy down the third equation. And then we can add them together. That's going to get me 5y minus 7z equals 20. Now you're probably saying, ooh, something looks funky. It sure does. We've got the same coefficient of y, the same coefficient of z, but different numbers on the other side over there. You might be able to start jumping to conclusions right now. I'm going to go ahead and finish this out because I want to get down to the point that we have something that we kind of know how to get to the answer from. So I'm going to go ahead and multiply the second equation by -1 in order to eliminate one of the variables. It will actually end up eliminating both, but that's okay. So if we copy down the first equation, distribute the negative on the second equation, then add these guys together, 5y minus 5y is 0. 7z minus 7z is 0. -20 plus 14 is -6. I have determined that 0 equals -6. That's not good. 0 doesn't equal -6. So this is going to be a no solution situation because that's not true, and there are no values of x, y, or z that will ever make it true. So we know it's no solution, so in our homework system, of course, we're going to answer that as does not exist. But here we're saying no solution to this system of equations. Now remember, we went through in the introduction to this that we want to be careful about infinitely many solutions. If we get infinitely many solutions at one early step in the problem, we got to continue on until we're down to where we're at now. So basically, if we would have got something like 0 equals 0 up here, then we still want to find the second equation. Because if the second equation is 0 equals 1, then the answer would be no solution. Because no solution trumps infinitely many solutions. But if we got something like 0 equals 0 and 0 equals 0 there, then we know that that's going to be infinitely many solutions.